Hi, this is at Migris. This is part 2 of our instruction video series for the new MigriX lightweight petroleum systems modeling software. And in this video we'll be looking at the generation modeling functionality in MigriX. So here we have opened a MigriX model, see in the 3D view, with 12 layers. And this particular model has one source rock, the 140 MA layer, and this is shown in the layer table by a source rock symbol, an oil droplet. And we have some different lithologies and some carrier rocks. So first of all, we may want to add some more source rocks. And then we go to the source active parameter and set that to 1 for the layers we want to activate. So here we do this for the 143 MA layer and for the 194 layer. Okay, so now we see we have 3 active source rocks in the model. These are shown in red in the 3D view here. So next we may want to add some properties for these source rocks, and we can then first go into the 3D view and say that we only want to show the source rock units. So then we're only showing 3 layers. We can pull them apart a bit to see a bit more clearly. So now we can go back to the source rock input folder and look at the source thickness, which shows the effective source rock thickness for the units. And we see this varies from 200 meters down to 50 meters, and we can change this a bit, set it to 75 meters for the 143 layer. Okay, so now we can change the TOC value for the uppermost source rock layer, increase it to 5%. We may also look at the hydrogen index. So we see that this is now set to 400 for the 2 uppermost units and 200 for the deepest source rock. So here we can pick the second from top and decrease it a bit to 250. So we have some variation. Okay. Next we may want to look at the kinetics for the same source rocks. So we select the uppermost layer and look at the source kinetic parameter. You'll see that this is set to the pepper B kinetic, and the same for the second unit. And the third unit is also default to pepper B. So here we may want to change this for the lower unit and select a different kinetic. Let's try with the pepper DE. After setting the source rock parameters, we need the update model. And this we do by clicking the update model button on the toolbar. We can then go and run a simulation, going to the simulation toolbar and selecting the run simulation to 0 MA button. And we see now that the simulation has started, and there's a progress bar running in the lower right corner, which shows how far the simulation has progressed. And as each time step is completed, the modeled migration will be shown if any carriers are active. And we see here that there's some migration in the lowermost layer. Okay, so the simulation is already finished. We can now look at the modeled maturities by going to Results, Maturities, starting with the maturity windows, which shows the main maturity classes, going from immature, which is shown in blue, through the early and main oil windows, which are in green, through the late oil window and into the gas window in the deep basins. And we see that there is some variation between the different source rock units here, and this is mainly due to the different burial depths of the units. Okay. We can also choose to instead look at the modeled vitrinite reflectance. So the color scale here now shows the modeled vitrinite reflectant values. We can zoom in a bit and show only values from 0 to 1.5. And we see that the most of the basins in the deeper part are higher vitrinites than 1.5. We may also want to look at the timing of maturation. So this plot shows the onset of the oil window. So this is when the source rock reaches the oil window the first time. We see there's quite a big difference between the two upper sources and the deeper one. We can look at the same for the gas window. Again, the two uppermost sources are mostly have not reached the gas window yet, only in the far north, while the values are much higher for the deeper source. We may also want to look at the modeled transformation ratios for gas, and this is based on the chosen kinetic scheme we have used. So here the differences will maybe even larger. So we see it also for the modeled oil transformation ratio. And if we want to look at the sensitivity to using different kinetic schemes, we can go into the TR alternatives folder and just browse through what the results would have been if we had used a different kinetic scheme. Okay, so next we may want to look at the expulsion values instead and look at how much is actually coming out of the source, and then we're taking also the richness of the source rock and the thickness into account. So we can start by looking at the expelled gas, and we see that there is some gas expelled from all three source rock units. We can also look at the gas expulsion plot, which shows just the expulsion in the last time step. We may also look at the same results for the oil, with the expulsion only in the final time step, and expelled showing the cumulative throughout the history. And here for the oil, we see that it's only the two uppermost source rocks that are able to expel any oil. We may also choose to look at the generated volumes of gas and oil, and here we see that there is more generated from the lowermost source, even though it's not able to expel any oil volumes. Okay. We also have some expelled windows plot, which shows groups the expulsion volumes into classes, showing where there's highest potential for oil and gas expulsion. And we see here that it's the uppermost source which is the most oil prone, while the two lowermost ones are more gas prone. So this may be a useful tool to quickly screen the expulsion model. We hope this video has clarified any questions you might have, and please use the contact information shown on the screen if you have any further questions. Thank you.